was just the pharmacological approach using blockers. Since pannexin 1 is present in all the cell types in the brain, we wanted to examine the contribution of microglial cells, macrophage cells in microglial macrophage cells. So we used the genetic approach. So we bought these comp mice which have the insertion of this cassette at the first intron and have a splice acceptor that produces a knockout at the transcriptional level. And this mice, they are leaky mice, which means that they only have 70% reduced mRNA levels for pannexin 1. So in that case, we wanted to create a global and a conditional knockout mice from this pannexin 1 knockout first mice. But we realized with time that it's like a long process which takes a lot of time. So as a preliminary data, what I'm going to show you here, that even though these homozygous pannexin 1 knockout first mice had only 70% reduced mRNA, we saw that these mice, they show a tendency to recover at day 3 post-injury in all the parameters measured as compared to the wild type mice. So with this, the conclusions for my specific aim2 are that administration of TVX reduces neuroinflammation and tissue injury, which was reflected at the levels of MPO, that it attenuates the infiltrating neutrophils. We also saw that our TVX treatment attenuated the accumulation of microglial macrophage cells as seen by the levels of CD68 and EBA1. We also saw that TVX reduces the tissue damage as measured by the levels of MMP9 and alpha-2 spectrin breakdown products. And finally, we also saw that TVX reduces the blood-brain barrier leakage. So, interestingly, we also saw that TVX, it improves the motor function recovery in CCI injured animals when compared to those untreated animals. And our homozygous pannexin 1 knockout first mice showed a tendency to recover post-CCI. So in total, this blockade of pannexin 1 channel may serve as a therapeutic target to improve recovery after TBI. And indeed, our data, in vitro data with the BFCF also showed that there is an attenuation at the level of ATP and migration. And the other student in our lab also showed, who is doing Thesis, has also showed that TVX prevents the tissue damage and improves the behavior in CCI injured mice. So with this, I would like to thank many people during my journey. First of all, I would like to thank my advisor and my PI, Jorge, who has immensely supported me, motivated me, and encouraged me to pursue this and brainstorm new ideas throughout my this process. I am extremely thankful to him. He has been willingly helping me, and his availability, his impeccable patience is like admirable. And I would like to thank my committee members, Dr. Bennett, Dr. Elkavez, Dr. Eugenen, and Dr. Harris for serving on my committee and giving me valuable inputs and suggestions. Dr. Harris, I would like to thank a little bit more because he allowed me to use his lab when we were first setting up our lab. And I would also like to thank Dr. Calderon, who unfortunately she's not here, but she always supervised me and gave me the training, scientific training that helped me to troubleshoot the new techniques. And I'm thankful to all my lab members, the wonderful people with whom I'm working with. They're awesome. And I would like to thank Jaya from the bottom of my heart, who has been an exceptional support. And in addition, I would like to thank Meloni and June for helping me for the behavioral analysis, for the knockout project, for the immunostainings, and all the past and the present lab members.